All right, we are live for day 19 of Advent Code, with an hour left before the problem drops. Mm. And today, well, yesterday was a tough one, wasn't it? I have a bit of cleanup to do on that, but I am also writing an article for day 17. So I was gonna spruce up my code for that. Oh, why do we have? I need to disable those tabs up there. Um, Day 17 article. Here we go. And here I'm really trying to simplify as much of this as I can. I mean, verbose, but very easy to read and intersperse text in for an article. Make sure it runs. What's going on here? Oh, yes, we don't have a point.origin anymore. We can just say point 0, 0. And what's this? Area.right. We can just define end. Okay, so we do have a grid, right? And in our inbounds, we're all over using the indices. I think we pull out indices as like X range and Y range. Yeah. Let's just define that right alongside a grid up here. Well, X range. Grid.head.indices. Exactly. Y range is the grid.indices. And val end is going to be X range.end and Y range.end. Or wait, .end. Let's say max, because the value of n depends on whether this is an inclusive range or not. It's often a pitfall. Okay, inbounds is not just X range. Okay, X range that contains X, and Y range contains Y. Oh, val end point and it doesn't know. X range.max, Y range.max. There we go. We'll just call that end right there. Okay. Heat loss. I wonder if I should define this further up. I mean, grid doesn't have to be the very first thing we define, right? So we can put our classes up above. Let's start with direction. I will put point in here. Well, a point does rely on X range, doesn't it? That's a forward reference. Yeah, I guess we're doing it this way. And heat loss is defined on a point. Sure. Like we could put it up there, but I think if we're reading this from top to bottom in an article, This is the order we want it in. Now, given that, we define our state, we define our two next states functions, and trajectory. There are other names for this. This is like a state vector. Velocity, the movement. I guess we call it the movement. Yeah, it's just a movement portion of the state. Let's rename that. Maybe the motion, just a bit shorter. Okay, sure. Yeah, that's what we will use. Um, Now let me pull up the website here, or rather the website code. And there are two branches there, so I think I should commit to the main branch first. Just add my code in there. So, okay. Wait, this is not a GitHub repository? Sure it is. That's weird. Git. Oh, this is an empty directory altogether. Huh. Okay. Well, let's get that again. Call it center / add in the code. Weird. Scala -center. Compository not found. Okay. Let's try to copy this. Yeah, this is a repository name, all right. Okay, now we've got it. And this is mostly the code we'll copy in. I wonder if these loose vowels here. Right, like maybe we shouldn't define our inbounds in terms of these. Like what I would do in my library is this is inbounds of an area, and we'll pass the area in. I guess we could pass like a grid in, and then do all of this stuff here. I think we'll keep it this way. Kind of Pythonic. Okay, where are we here? Oh boy, that is slow and I don't know why. I hope our internet is all right. Yeah, our stream health seems okay. Oh, Sweet Radish, she made it. Awesome. Well, congrats. I was just looking at day 17. I am writing up an article for it for the Scala Center. So this is the code I was going to use. Mincost.getRels default next inf. Okay, yes, yeah, a min cost map. Is that's Java? And I assume that's in your while loop for your search or your Dijkstra. To prune it, I don't do that. I'm doing this here, where I just dedupe sets of this triple here of position, direction, and streak. Yeah. Have you done in the past advent codes? Or advents? I'm trying to download this so I could write the article, but it doesn't seem to be resolving it properly. It's stuck. I don't know. Um, there are usually a few every year. Last year, I think I want to say there were 3 of them. Day 24, day 16, the one with the elephants. That was a tough one. That was a really tough one. And there's one earlier in the year. I don't think you even need a Dijkstra though. You could just do BFS. I ended up using A star for day 24, and I saw an improvement. Oh no, I have not written any of them yet. I was scheduled for day 11, and we switched things around, and someone else piped in instead. So I'm writing day 17 and 23 when that comes out. So this is a little bit late. I've been busy the last couple of days. Oh, if it's by me, because it'll be super concise. Okay, let's try this again. Clone the repo. Hopefully this doesn't stall. Okay, it didn't stall this time. All right, and let's look at the readme real quick. Put up ID 2023 and just open with code, sure. Okay, so here is an example I want to follow. I'll leave that on the right, and I'm going to save a new file, day 17.scala. And we're going to take my article, copy paste that right in. Well, not article, just a code. Is this stuff here needed? Yeah, I suppose this is needed for load input and whatnot to work. So we need a part1 function that takes the input string. And then, I mean, I think all we really need to have is a part1 and part2 unit functions that print out the right answer, yeah? Okay, so this here is not going to work anymore. This is Scala 3, yes? Yeah, it is. So that will be moved to some sort of parsing code or whatever. We'll follow these imports. Based on solution from C squared. Just have no dashes. Source main Scala 2023. Oh. And then day 17.worksheet.sc. There we go. We'll copy out these imports. Or not the imports, the main defs. Okay, now I'll follow the pattern here and do a load input function that gives me this grid. Yeah, that way we can just pass this whole thing to functions. I mean, we could also put this at the very end. Well, let's see what they do for load input, because the way they load their directory is going to be a little bit different. I see. Load file sync. We'll copy that over as well. Hmm. And yeah, we could turn these into defs. I mean, we could just make this search. And then where's grid use? Using a few things. You could just do this in terms of a load input. The load file sync. And my input today is not a string necessarily. I'm going to put this whole thing up here. Okay. So what does this do? Oh, hold on. I overwrote whatever they had previously. Load file sync. It just loads the whole thing as one string. So we have to like split. Let's take a look at it. Yeah, it just concatenates them all into one really long string. So we have to split onto double new lines. We're gonna take a file and we're gonna split on a double new line. And then we're gonna map and do this thing here. So for each string, we do as digit, 2-vector, and 2-vector at the end. And I could probably make that nicer. Let's see. Let's do look at vector.from. This will be like a vector of int. And we're gonna do for line and file.split. And we take well, for C in the line, we're going to yield C dot as digit. We could also just do this map here. We'll try them both. Okay, so for line, we're going to yield line.map as digit.toVector. Yeah, I like how that reads better. Okay, and then now down below, this grid is going to be load input. Okay. Let me take a look at day to see where they define case classes and all. Okay, they don't define all down below. They even define all these vals down below. So I think we are good. So instead of having these answers here, we're just gonna go search. Um, yeah, search with a function. What was it? Next states. Search next states 2. Okay. Now we need to add input files. Let me see where those are. Input. So like here's one for day 15. I'm gonna save that as day 17. And we're really not supposed to put like the main input in here. So I'm just gonna put the example input in. And then people can always put in their own inputs if they want to get their own inputs, right? Okay. Now let's try running this. Oh, we have issues with this apparently. Part 1 is all defined as method part 1. Oh, hold on. This is day 17 package. Okay, now we can run these. No elements removed from the heap. Okay, what happened? I'm guessing this is some sort of state issue. Like maybe this hasn't all loaded. Well, we do get a few states. No element removed from a heap. No, we don't need a map. See if part 2 runs properly. No, we're not going to add this right now. Terminal will be reused. Exception, no element removed from a heap. No, that's from the previous one. Hmm. Okay, let's look at my code and let's look at the states it goes through. So for answer 1, we're visiting 0001, 1011, 20. Okay, and for this one, the first bit 0010, 20. Interesting. Why doesn't it visit 01? Seems like it's not enqueuing everything. So let's show everything that's in queuing. So states for each. We're just gonna print line and queuing s. There we go. And we'll try run part one again. See what's behaving differently here. 1020 is 25. And that is patently what's not what's happening here. 00, 00, right? And then we have 01, and then we have 10. Weights 3 and 4. And this is operating on the example. Make sure the grid looks the same. So I for each. Oh no, that's gonna be a single. Yeah, I for each print line and return I. And try run again. Oh, it's all in one line. I see. That's interesting. I've misunderstood this then. Load file sync was it due? We take it all and we just make it one big string. Let's take a look at that string. I want to know what we're working with. File. And this grid here could go back to whatever it was before. Okay, I mean, that looks correct. Let's see if we can print each of these lines separately. Oh, not a double new line. It's just a single new line. There we go. There we go. All right. That visits too many states and then returns a solution 102. Okay, let's take out this print line. Don't need to debug anymore. See the line lengths here. 76, that's fine. Okay, so we have new stuff. Now we can see what's new. We'll add those new files. And add solution input for 2023, day 17. Okay. Oh, we need to add our own remote. Let me do that quickly, just in the other window. And while I'm at it, I'm going to set an alarm in case I go too long at this. That timer for 29 minutes. Okay, so remote, we're going to add myself as a remote. Yeah, I should have forked this repo first. Okay, now I can push. All right. Let's go ahead and open that repo, or open that pull request for code. Scala admin of code. And it should notice I pushed. Doesn't it notice that? Is that only when I push to my own repo? Let's see. Let's look at st squared. Okay, here we go. Open a pull request. Um, yeah, that should do. Hey, Betsy, how's it going? AOC is going all right. I'm a bit slower this year. I've only been in the top 1,000 once. So I'm rusty, but I'm having fun. Right now, I'm just, I don't need to write a description. I'm writing up the article for the Scala Center for the day 17 solution. So I've added my code, and now I need to add another PR for the actual article itself. And what do I need to do? I need to switch branches. Any memes planned for us in the last 6 days? Memes like what? Like the monkeys last year and their antics? That friggin' puzzle cube. You remember that one? Or the grid map, the mesh net? Yeah. Today won't necessarily be harder than yesterday. Usually the hardest for me is like between 17 and 20, somewhere in there. There's like a curveball that they throw. Last year it was 16 for me. The one with the elephants in the rooms, the tunnels. Yeah. I mean, there were a few. Like day 9 was definitely too easy. That felt like a day 1 problem. That was the easiest easily. And day 1 was surprisingly difficult. I was expecting like a 5-minute typing race. You're not streaming at Code, are you, Betsy? BetSimp? Oh, is it BetSimp? I've been reading it as like Betsy MP this whole time. Yeah, but I hear him. It's hard to have it really be progressively easier all the time or progressively harder. Okay, so this part is done. Let's see. We're gonna check out Git branch A. What's it called? Website. Gitco website. we're ahead of origin main. Okay, I'm gonna have to change that to. Wait, why? Was this already? Oh, right. I didn't open up a new branch. Okay, we're gonna go back to. Wait, but this is on main. Are we still on main branch? I thought we switched to website. Oh, okay, okay. Right. Gonna check out from Stu Squared / website. Okay. Now here. The README. This doesn't work for me for some reason, but I think I could still at least write something and open up a pull request. Could not determine. Um. Oh, it doesn't even know where we are. Hmm. GitHub, Scala Center. Yeah, I forgot to fork the repo first. And I'm too lazy to copy my stuff over. Mm, okay. Here we go. Now let's run docs/mdoc. I don't expect it to run properly, but what can you do? Okay, so we're gonna look at like day 2 as an example. It's 2023, or is it docs 2023? Puzzles. But this is day 1 2022. So where is 2023? This is 2022. Oh, this is 2021. This is 2022. Where's 2023? Let me check my commit history here. Hmm. Oh, I think I already had this forked, didn't I? Okay, I need to go to my repo. I need to pull it. I'm gonna rebase that onto like another branch. And then we'll open a new pull request. um, Scala admin code. And let's look at git show head previous. And this was done in 2022. Okay, I'm gonna check this out as a new branch. 2023 day 17. We're currently on website. Oh, and this is showing up on the website branch. That should have been based off main. It show. Let's look at what changes here. Oh, wait, this is a commit from me from ages ago. Okay, so let's just do a git pull then. Oh, hold on. I need to pull from upstream. Git remote. Okay, you don't want to watch me mess with this. We're gonna go back. Okay, where were we here? We're now in branch website. For some reason, it shows that because we're using stu square as my upstream. So let me just change that. Um, remotes, and let's just change our upstream. Oh, nope. I think we just want to change the upstream of this branch. Okay, so branch, there we go. That's what we want to do. Um, we set it to no origin/website. Okay, now we have a lot unpulled. We're on my own branch website. I think we're gonna make this a new branch, git co b 2023 day 17 website. And then we're just gonna hard reset this. Reset hard to origin/website. Let me make sure we are on, oh wait, gitco website. This is what we're gonna reset. And now we're up to date. I'll just do a quick pull just in case. All right. Now we can find this code. 2023 and day 17 left as a template. Yeah, I know it's been pretty flat this year, hasn't it? And in fact, it was like a dip downwards around days 8 through 10. And it didn't start off as easy as it did. Although people did give up in the last 2 days. Good morning, Blue. Good morning. How much time do you have before stand up? You gotta solve this in an hour and 45 from now. It's brutal. um, let's look at day 17 and oh, this is 2022. That's why it's there. Right. We don't want 2022, we want 2023. puzzles. Day 17. Clumsy Crucible. And I think for reference, we'll open up day 2 from this year. And might as well add solution. Oh, where is the... Okay, HTTPS // advent of code. Yeah, we have a link in here somewhere. Let's open it up properly. A17 stew. What we want. Okay. I2 squared. I remember the Tetris stuff from last year, which is pretty nasty. Day 17. Yeah. Although, I mean, I'd say like that. That was nasty because of how you had to hard code like the shapes. Like I thought day 14 this year, which also did cycle detection, was more fun. Okay, there's a final code. Oh, they just start off with final code. Run it in the browser, run it in the browser section. Wait, where's the write-up? There's no write-up. Okay, so final code. We'll just copy over the run it in the browser section. Where's my final code? We'll put my final code here on the right. Except this isn't what I ended up submitting, is it? It's in another branch. It's in the pull request. I suppose I could copy it from the pull request. Or I could check out a work tree. Okay, GitHub, Scala advent of code. And let's just look at the raw file here. Wait, how do I look at just the raw file? V file. Raw. There we go. Wait, this is day 2 of 2022. That's not the one I wanted to open. I wonder why that keeps opening up. Okay, here, day 2 of 2023. That's what I want. So we have a solution summary. Part 1, framework. Okay, we can do something like that. Parsing. We'll follow the same structure. And final code at the bottom. Copy it from here again. Okay, and in their final code, I'll leave it as a copy of this for now. The final code doesn't include, hopefully like parsing. Where do they handle the input? Yeah, they just call it like an input string. I'll just leave it as this for now, and we can modify that later. Ichi and Simon not streaming. Simon is on holiday right now, so I think he is still solving the problem, just not streaming. And Chi-Chi, I'm surprised he's not online right now. He usually is like an hour early. So, I know. Maybe you're stuck with me. Um, okay, there's like a browser run thing. We'll add that in right before solutions from the community. So day 17. Okay, so part 2, summary, part 1, summary, and then an overview. Part 1, okay, we'll do the framework. And parsing, I don't know if we really need to cover parsing. So we have a part 1, we have a part 2. We'll add a framework under part 1. We do have a framework. I think to be really effective at in these challenges, you have to practice a lot and know a wide range of algorithms. Yeah, yeah. Like those area algorithms, I ended up like driving my own for yesterday's. But there's Pix algorithm, there's the even odd rule, there's the shoelace thing. None of that is stuff I knew for yesterday or even for day 10 when we were doing something sort of similar, calculating area. But probably the best way to practice is just to do the past years, right? I still have 2015 through 2020 to do. Okay, so this is a classic search problem. With an interesting restriction on state transformations. We'll solve this using Dijkstra's algorithm. Modeling state transfer. Yeah, modeling search state transformations independently from the restrictions introduced in both part 1 and part 2. Maybe I'll like link to Dijkstra or whatever. But basically, min cost less restrictions is what I'm trying to say here. You did yesterday's coordinate compression, because I didn't realize one could do the shoelace thingy. So basically make all coordinates exactly 2 apart and remember the original widths. Okay. Yeah, so I guess that's sort of similar to having like an interval type in a sense, or an area type, which is what I used. I'll say I basically did the same thing. Uh, what were your rules for adding spaces though? Because what I did, let me pull it up. But I don't remember if you saw me like talking about the solution I would take. I essentially did like when I was walking north, I would add the full area to the right, and when I was walking south, I would subtract the full area to the right, which is sort of like a simplified special case of the shoelace thing. Um, and then when I was going east and west, there were some edge cases where those boundaries were added too many times or deleted too many times by the north and south. So during the east and west, I handled those edge cases. So north and I separate into two parts. This one just calculates north and south. And for for east and west, I had to have I had to have the previous direction and the next direction in scope. So I had to like zip those together. And this big this big match here is essentially um, these cases here, right? So if we're adding to the right, oh, oops, we didn't do that. Yeah, can I just move it back? I can't undo. Maybe I click this here. Yeah, so this here is my edge case handling, right? So if we're moving north and we add that area again, then there's an overlap between those two areas. So I'd subtract this line area. Similar for west, and the green and red just represents what I'm adding and subtracting in all these 8 cases of moving like south and then west and then north or stuff like that, right? Um, I mean, I still sort of call it coordinate compression because I am using areas that are sort of like a coordinate compression, right? They're not adjacent. They're not adjacent anymore. I'm not like changing the coordinates, but it gets the same kind of thing across. Yes, yes. You make note of the width and then do exactly. Um, yeah. So that's what this was, and it was gnarly, and I had to debug it and all, but it worked. I honestly thought I thought my code would look like this when I first conceived of this idea, and I thought, okay, we'll handle a few edge cases when we're moving east and west. I didn't realize I'd have to handle like 8 different cases here. Okay, that is our clock. It is time for the problem to drop. We're going to put away the Scala Center stuff. Um, where is the other one? Okay, this one we're just closing. And let's pull up Advent of Code. 1 minute left. See you on the other side. Good luck, good luck. Oh, I need to make my worksheet. Let's see, let's just save this as day 19. And day 19. There we go. We have files that we should just close out so they don't show up in our errors. Five seconds left. Here we go. Good luck, good luck. Okay. Ah, interesting. Hmm. Are these like operations? Is that like a map? Okay. What do you get if you add together all the rating numbers for all parts? Okay, we're gonna add all the rating numbers for all parts. And what is my input exactly? Uh, Avalanche machine parts. They're forming a heap. They are organizing. Elves are organizing parts. And they have a system. Cool looking, musical, aerodynamic, and shiny. Okay. And each part is sent through a series of workflows that will ultimately accept or reject the part. All right. Each workflow has a name and contains a list of rules. Okay. So these things here are the workflows. Once it's sent through a workflow. Okay. Each rule specifies conditions and where to send a part if a condition is true. First rule that matches the part being considered is applied immediately. Okay, so we have multiple rules. The part moves onto the destination described by the rule. Okay, so I think we want a map of workflows by their names. So consider workflow X with these with these rules. It's named X, contains 4 rules. This one here, if the part X is more than 10, send the part to the workflow named 1. Otherwise, if the M is less than 20, send it to the workflow named 2. Otherwise, the parts A is more than 30, reject. Rule A, otherwise, accept. Okay. So a rule has a condition and a place to send it, or accept, reject. If you can sort a few parts and give you the list of workflows. Okay. Is there a list of parts at the bottom? I see. Okay, so parts have these 4 stats. We can do we're gonna do an input get lines here. And case class, we have a rule. How does it know? How does it know there's a rule? That's so weird. So a workflow is basically a list of rules. So we're just gonna do a rule. And there's some sort of pattern, and there's a send. There's something we're sending it to. Uh, we'll call this a condition. And we can model that as a string for now. Field trait send. Do other workflow. So to workflow. Wait, what's it? Send part to workflow. Accept and reject. So case object accept. We're just gonna call this 2. The rule has a bunch of a list of conditions. And condition for now is a string. We're just going to name it to that in case we actually change that. Type condition string. And then we're going to take while non-empty. So we want the workflows. Val workflows. And this is going to be a map. Map. So we have a string to a list of rule. Default value. I don't think we want a default value. And let's see. What, we'll do this while lines equals input dot take while non-empty. Then we'll do like a list buffer. Dot mutable dot list buffer, and this can make rules, I suppose. I guess we could just map these lines. Okay, line lines. We're going to yield something, or rather, lines.map. And now parse a rule. So there's a name followed by curly braces. And then we have raw rules on the inside. And then val rules equals raw rules, not split on a comma. And I mean, these could be functions. We have categories. Let's just add the categories. I might over modeling this. I might be over modeling this. Category. So case X M A shiny. Oh, Christmas. Okay, I get it. Okay. I guess this is fine for now. We'll just use the strings, and maybe we'll parse that into like integers and whatnot later on. We'll have to. Oh wait, each of these rules, each of these conditions. So this is going to be a condition followed by a send, right? So we're going to map this to a list of rule, string to rule. Hey Muga, how's it going? We are doing Advent of Code. So raw rules. We split it into these, and then we're going to map each of these. The case, we have condition followed by a send. And the rule will have the conditions. I guess there's one condition per send. Yeah, it's not a list of conditions, it's just a condition. Condition. And then send. Let's do this. Case object send def from string RA or name. So S match A R S is 2S. Okay. Send that from string. Well, we'll do that send string. And then just do like name to that rule. Yeah. Oh wait, we have several rules. So we take the name to that list of rules. Name to rules to list. Okay, we parsed all the workflows now. We have a problem somewhere. Nope, we need this arrow here. There we go. Rules is a list of rules. Wait. We have string to a list of rules. Okay, yes, for each a workflow does consist of a name and string and a list of rules. Okay, here. There we go. Match error on A somewhere. We should have done this in smaller sections. Okay, so for each of these lines, we're going to convert to a name and a list of rules. We split on the comma. Let's make that a to list right now. And for each of those, there's a condition. A, I guess. Oh, R and A get parsed differently. I see. So R and A don't have conditions. So R and A are actually rules. Okay, it's good to understand that. Okay, we're gonna have a sealed trait rule. And I guess this is just a case class send now. And these two here, send rule. We're over modeling. It's gonna take too long. And we'll call this a conditional. So here's the condition, and that also ends. I mean, modeling encodes my assumptions, right? And it's forcing me to get that right. So in the case of A, then it's just accept. This R is reject. And otherwise there's a condition in send. And we do a conditional condition and that from oh no, just send. There's no more from string. We don't need this here. Match error of an FGV. Can you have something that just doesn't have a rule? Let's look through our input. Lines find that starts FGV or whatever input. Get lines. We already did the get lines, okay. Yeah, FGV and embraces. So that should be fine. So that's name, preceded by the vowels and the colons. What am I doing with name? I'm not doing anything funny with it. Which line exactly? So it's inside the list. Dot map. And then we also have our input data, right? What do we call it? We have items. So there's like an in rule. And if s is less than whatever, you go to px. Okay. Or an in workflow, rather. Okay, we're just going to take this and apply it to a rule. So let's copy one of our strings. So why does FGV fail before other stuff? FGV. Oh, okay. When you send, you can just say, as a catch-all, you go send to FGV. So a rule doesn't need to have, a rule to send doesn't need to have a condition. Okay. I guess just sending something is also a rule in action. Okay, so you can have like a conditioned action or just the action itself. I see. And each of these has a list of rules. The order matters. We can accept, we can send, or we can do a condition, which I guess they're you go to one of the base rules. So action, base class action. Or rather sealed action. Please extend action. And then just send itself is an action. and a conditional extends a rule. Okay, that works. That works. That's what it's failing to parse, was that last bit there. So if there's something here, we have send is this is just the action, and you should be able to parse that. Case object action f string, or you know what? Yeah, so otherwise this is just an action. You do like action not from string. String. So an action has a from string method. Accept, reject, s, send s. There we go. So this conditional action string action. There we go. Okay, this is a list of conditional or string to action. Oh, right, we have to actually call a function. Now, action is also a rule. Filtrate action extends. There we go. Now we have workflows. And then we have the items. Parts, we'll call them parts. Just a bunch of values. So x is, and there's all ints. M int, a int, s int, object part, def from string. Not quite that. There is curly braces. They are comma separated. We have like an x equals, m equals, a equals. So for x equals 22, y equals 23, all parts should be matching to. I think if any rule matches first, the first rule that matches any of those things. Okay, so we're gonna move this up above with stuff here. Then val parts. Part. Do it this way. List dot from. And lines dot map. Right. Yeah. Yeah, I'll just do list it here. Yeah, that's lines. Okay, we have a list of parts. Ultimately, 3 parts are accepted. Whatever. Okay, so we handle a part. Def process. We can call it process. Yeah, process. starting with some sort of workflow, right? I guess we want to start with the end workflow. So those, what's the return type here? You want to know if they are accepted. So I guess return type here is an acceptance or a rejection. Yeah, accept or reject. I guess this could be a boolean. Let's do a boolean. And it's going to be an unfold iterator dot unfold, and the beginning state is well, we have our part. Part's not proper state. The part doesn't change. We have a workflow. So we're gonna do like workflows in. Okay, so I guess at each step we like return another action, which then potentially gives us another workflow. I think we want like a sequence of names of workflows. Orphan of Cthulhu, thank you for the follow. I don't like this stuff here. I suppose we're applying an action to a part. And what we return is a series of actions. So the first action is sent in. And we get an action. Every workflow results in an action. So like a list of rules. I'm gonna write a separate like apply workflow function. Def apply workflow to a part. And I guess the workflow is a list of rules. Okay. Um, now applying this workflow, I guess what we want to know is what rule applies, right? That rule could be an action or a send. It could be a conditional, or it could be an action. Just one of these. So when we apply rule, we get some sort of action. Yeah. Um, so I suppose we're gonna fold left here with like an early termination. We see which rule applies. F applicable or val low. know how to find. So if it's conditional, whoops, yeah, that's exactly it. There we go. If it's conditional, we see if the condition applies and does apply. Then we take this action or this, yeah, that action. And if conditional applies, so I'm going to match the conditional. Where we check it. Condition match case. So there's like a variable that can apply. So we have the category, and we have an operation less than, I guess it's basically less than or greater than, less than, and we have a value. So I think it'll make this nicer just to have a class for this condition as well. The case class category operation and value. Or, we'll do like this seal trait condition. And we'll do like a less than. And this extends a condition. And case class greater than. Okay. Object condition. We need like a from string value.toInt category from string. You know what we can do? Category dot value of name, value of category dot upper to uppercase. Yeah, that works. And then value dot to int. Yeah, let's do that. To uppercase it. Then we have f applicable to part that category. Okay, so let's define that part. Um, value given a category. Okay. category value. We'll call it category value. Or, we'll just call it category. There we go. That matches. Type condition needs to exist. Now we need to do. Now we have a from string. Do we have a from string condition? Yes, we do. So we have a condition from string. There we go. Hey. So if condition dot applicable to our part, and we return an action. Otherwise, if it's not conditional, we just return. Otherwise, it's an action. Oh, you know what? Let me make this like a first. Okay, so rule can be a conditional or an action. And we will ignore conditionals that do not have an applicable condition. Otherwise, we just return that action. And we can do iterate or not iterate. I don't know. Let's look at this. So we're given this workflow. We apply this workflow to get some action. And we will progress the state. So if there's a next flow, maybe we should unfold on action. So we apply a workflow to get an action, right? What we could return is a sequence of they're being applied. We have a starting action. Yeah. Workflows. Okay. Now we take our state, which is some sort of action, and we're going to match on that. So case accept. Let's send to, and that's the next action we return. Okay. Define like a terminal here. Terminal. Doing something. this is actually false. Otherwise, it's true. Okay, so now we can do. We have an action. We have a next action when, let's say unless the action is terminal, um, and you know what? We can do this. These two cases are just a none. We don't even need the terminal thing. So we have a new action, and that's what gets returned. The state becomes the right part is the state. The state, I guess, is just the actions. I suppose the state could be the workflow. No. This is the next list of rules. So we're going to apply workflow. Oh, wait, we do apply workflow. I guess we just action. Um, although, like, what I want to return is like where things are, which I guess, yeah, would be sends. Like this is an action. Okay, so you just have some action to action. Okay, so now we have actions. And you know what? Let's return that list of actions. That's exactly what we'll return here. And then we'll make the boolean. So def accepted part process part dot last match. This shouldn't happen. Accept true and false. So parts.count accepted. And that should be our ans one. Oh, okay. Modeling it so heavily. I mean, at least I'm gonna be pretty sure this works, right? Once it compiles. Um, let's just make this from string. Gory dot value of, this will just be from string. Just clean things up a little bit. This can be just be a C. V. This can just be a V. Here. What's the issue with that? That is returning an action. Oh. Apply workflow. Oh yeah, given that part. So part. And this here. Oh, we don't need to make this be applicable. Or it can just be action not get. Okay, 121 for part 1. Bit too long, but hey, first try. Okay, okay. let's look at examples now. And now we can debug this pretty nicely. So day 19, 2023. I'm gonna save that as example. Okay, and it gets the right answer, 3. So we can do, for example, process parts 0. We'll just do it first part. And then that makes string with arrows. Then QS and lnx accept. That's where it goes. Let's see if that's accurate here. So in QQZ, QS, lnx, then accept. So I did get the accept, but I think I got it the wrong way. This thing here, this can be an iterate, right? We're basically taking an action to an action. Iterate will return the first value that we use, right? So iterate. And we can redefine this. Accepted is simpler now. It's just process parts, not contains, accept. Okay, so basically, depending on the action, we do another action. I guess in the accept and reject case, we're now just continuing to return that. That's the only place you can go from there. If it's send, yeah. Oh, if it's send, Yeah, so we apply a workflow, we get a new action, and then we just return that action. It returns an action. Found required found required action dot type. That does return an action. Oh wait, we iterate. We iterate on the start action. We don't want to do that big make string now. Process. I guess we'll do like a take while. While not terminal, but to list. Sure. So part one, this is where it goes. That's that org each. We're gonna do this. Process that part. Actually, we're gonna make string. Yeah. Um, wait, what's going on here? We must have errors somewhere else. Nope. Just close that for a sec. Oh, you just got part one? All right. Well, good luck. Just in time. Yeah, just in time. Oh, I still need to get part one. I thought I had it. It works for the example. I'm trying to do more debugging right now. What's going on? We're having. Hold on, whatever we're doing. You know what? I like my unfold better because I could at least get it to make sure it terminates, right? I'm just gonna do a quick refactor there. No, we're gonna do a bunch of. Oh no, yeah. This is an unfold from the start. We have an action. Val action equals that, and then action to action. In these two cases, we return none. There's no continuation from there. Okay. Definition of accepted doesn't actually need to change. But now we can do this process, and then we just make string. This is not a standard error. This means that my worksheet is bugging out. I hate this so much. Metals, restart server, sure. Let's see if that does it. Rank 140 on part 2. Nice. So, yeah. I have to think about that later. We have release of the year on schedule today. Okay, fair enough, fair enough. Had some bad debugs for my part 1. I honestly really thought I would have no debugs. I'm just gonna restart my worksheet altogether. my first action could be send to n, right? Send to n. Yeah. Want to see. I just want to see my strings here. Process part. Okay. Process part 0. Okay, we send to QQZ, QS, and then LNX, right? That looks good. Why can't I do that for each of my parts? Let's look at how parts is defined. I guess we just line by line. Here we go. So part 1, the second part, gets rejected. PX, RFG, GD, reject. Okay, I mean, that looks good. Why can't I just do this here? For each, oh wait, we need to actually print line. There we go, that's why. Okay. Accept, reject, accept, reject, accept. The last one is PX, RFG, accept. I mean, okay, so like, it is perfect. Yeah. um, it's absolutely perfect. What's wrong? I tried 121, and I didn't like 121. Okay, let's look at where everything is going then. We'll just copy that worksheet output and go to a scratch buffer. Okay, this is what happens to every part, right? A lot of stuff gets sent to FPJ. That makes sense. I suppose I should print line that part too, so I can verify those rules. Like maybe there are rules not checked by test. Let's see what's not checked by the test. XMS are all used. Oh my god, you don't count them. You add together all of the rating numbers for all the parts that you ultimately accept. What are the rating numbers? Okay, okay, there it is. I did have it. Okay, look. This was long, but I wrote it, and when I compiled it the first time, it worked. Right? I have not changed anything about the logic here. This is where modeling comes into play. So a part needs to have a rating number. Class part def rating number. And what is it? Adding all the part. You just add XMANS. X plus M plus A plus S. Okay, so ands parts filter accepted map rating numbers dot sum 509597. Okay, 509597. Okay, let's look at part 2. Rather than sort parts individually through all the workflows, maybe you can figure out in advance which combinations of ratings will be accepted or rejected. Okay, each of the four ratings can have an integer value ranging from a minimum of 1 to a maximum of 4,000. Oh, yes. Okay, it's gonna be fun. Um, let's give myself a little break. What did I do? I did 4,000. I was slow, but maybe I can catch up on part two. How many people? So I want to look at stats for day 19. Okay, I can be in the top 1,000 for part two still. It's going up quickly. It's going up quickly. I'm not gonna be in the top 1,000. Um, and have an integer value rating from 1 to 4,000. How many combinations of ratings will be accepted? Okay, work backwards from accepted then. Ah, this does make me feel good that I have models. Do I want to refactor anything real quick before I continue? Let's see. This category, that from string, this can be, what? Where is it? Category dot from string. Let's make this from value. From value c dot to uppercase. Okay, we'll just get rid of some code. Conditions, so parsing all of this stuff. Yada yada, rating number. Sure. So we're not gonna pipe 4,000 of these through. We know that much. Oh, we have an issue here. From value. Oh, category dot. That is a from value. Dot value of. That's what it is. Value of. Okay, I'm just gonna commit this real quick. 2023, day 19. So 2023, day 19, part 1 is solved on stream. And we start thinking about this flow. And I guess let's take a look at all the ones. So workflows, you can comment this out. Dot filter. I guess we want to look for, so given the rules, does there exist a rule that is an acceptance? I suppose we go backwards from the reject too, right? Like assuming everything will be either accepted or rejected, right? Yes. Yeah, just shorthand for git commit. Okay. Let's just do a couple tests. So parts.count, process contains accept, will count, reject. I want to see which is bigger. Parts.size. So more are accepted than rejected. Oh, I mean, maybe that's not too helpful. So do any of these rules. So some of the accepts, right? So like this, some of the accepts happen as part of conditional. So we're going to filter for workflows that contains an accept. So we have name and rules. Sure, let's do name and rules. And we'll do like a rules that exists. And we're going to do a match here. Or not match, just a case. Um, Conditional or an action. So case accept true val accepting workflows. Um, Anything else? So let's see. We have an accept and a condition. This is true. Anything else, it's going to be false. So workflows.size. What's that? To tell me. Not found workflows. Wait, really? Workflows is defined right here. Oh, workflows. That size. And then accepting workflows that size. $354. And let's calculate like a rejecting workflows. Val rejecting. There we go. So rejecting workflows. What size? And for each of these accepting workflows, we can see if there's a conditional. And basically, we're going to pass like a bunch of, so all those conditions have to pass to get there. And then we need the name of that thing. So we'll return a range. So we need like sort of a can pass on a condition. Yeah. And I guess have like a range per def can pass and given a category. We're going to return a range. And then otherwise it's until 400. Right, values can go from 0 to 4,000. 1 to a maximum of 4,000. Okay. And then we'll take like intersections of those ranges. In fact, I'm going to use my interval class. Here we go. Yeah, so interval. It can't be v itself. So 0 till v is good. And then interval v plus 1 to 400 or 4,000. Otherwise, as it can go from 1. Okay, so 1 until v, 1 to 4,000. Interval, we'll make an interval of ints. Okay. So I guess we can start with like a passing intervals, and for each accept, we can kind of work backwards and like see what has to be passed. Yeah, look at all the conditionals that have to pass to get there. Now, I did see cases that we should think about. So like AA, right? This conditional here does not matter. Because if we fail that conditional, um, if we match it, so m is less than 1126, then we still go to A. But now here's another case. Okay, this has 3 ways to get to A. But then again, like these conditions don't matter. Because if these conditions don't pass, if none of these conditions pass, they're all A's, then we accept. Kale accepts everything, right? I don't know. Apply workflow. Workflows end. You know, we should just give the name of the workflow in our apply workflows method. So our name is a string. Workflows name. Yeah. And you just say 2. I guess send. It's gonna be like a workflow name, right? Um, yeah, okay. So like this match and the send, for example, just name apply workflow name to a part. I don't know why we have this thing here going on. Yeah, so we might do like a normalization step just to remove some of this complexity here. And from here, like we search Q's, right? So we have a set of valid ranges. And we go down like a whole tree in reverse, and then we have to like take the union of those ranges. I think the sooner we take unions between intervals, the better. Um, let's give a can pass a shot. So accepting workflows. Let's take the first one. That head. What does it look like? So it is. Wait. The first is just. Oh, yes, yes. So the name is MVP, and then the rules are conditional, conditional on S, and accept. And I suppose we have to take the intersection of all rules leading up to it, right? So we can do that. Def valid ranges, and then we intersect that with our current set of ranges. Um, we make a ranges object. So ranges, just to avoid whatever. Yeah, X mess. There we go. Saves us some typing. But given a workflow, you know what? I think workflow should just be lowercase all the time. Let's do a quick find and replace workflow with workflow. Everywhere it's just fully lowercase. Sure. Thank you for the follow. um, and then now for each of these rules, we pass valid ranges through it. Okay, we're gonna shelve this for a sec and just do this on a single rule. Then we have to take the intersection of all of those ranges. Mm. Okay, if there's a condition. Wait, valid ranges on action. I don't think that works. Oh, yeah, I don't think that action matters. Uh, the reject will matter. So we're gonna look at reject separately. Now it's a triple question mark. And then here we don't have a thing. Let's say this is a send, right? It sends it away from the accept, sends it away from the thing that we're trying to reach. Why am I doing this backwards? Shouldn't I just do this from the start? Yeah, I think we should start. Let's start from the in. We won't work backwards. Everything we're doing still works. We're just not going to use these things that we've pulled out. We're rejecting workflows and accepting workflows. But we do need to normalize. So def normalize rules list a rule. Return another listed rule. Okay, so we'll start from the front and we'll see if we get through everything. Um, I think I want to make this like sort of a method on a part. Okay, so valid conditions given a rule. So let's say this is a, then we have this condition. We're going to look at what can pass through each of those intervals. And what we might do is make this a method on our ranges class that sort of further filters each of these ranges, right? So def filter by rule. And then we do that for each of our ranges. Now we take our condition. No. We take our condition, and where's our can pass? We check that for whatever category. I think we match on that condition. Yeah. And we try to get like a category. The category matters here. Let's do a def category. Or you know what, like well, yeah, let's do that. What's this? You know what? This can be undefined. So now we can do condition dot category. We'll triple question mark this. And we check, I guess we match. So we take our, oh, this is exactly what I was gonna do. We take our current range. This is almost what I was gonna do. It's not actually correct code. Yeah, to get to A from N. So these are the ranges that can pass this condition. Now we intersect that with whatever we have here. I guess each of these ranges are actually going to be a list of intervals, aren't they? Yeah. Yes, they are going to be. So let's make that change. List of interval. Okay, so if the condition is on X, then we have to change X. Can pass. I guess this is like all the X's now. So X, we're going to take all of these ranges in X and intersect them with, and then that's like a flat map. That flat map. And each of those we intersect with our condition. What do we call this range? Condition that can pass category dot X. Now the answer flat map for each of these we check for each of these x ranges. We're going to check if they, we're going to intersect them with that range. Yeah, that's what we're going to do. Okay, case. And we do the same kind of thing for each of these. It's kind of boilerplatey. I feel like there's probably a nice way to do this. But you know what? We have good autocomplete. Maybe. There we go. Okay, so our ranges will start. Val start ranges. There we go. And then we're going to take start ranges, filter by workflows in. And we'll do the first rule in there. So XMA, A gets filtered. Might make a nicer two-string on that, but we'll do it later. And we do that for each of the rules. So what can we do? We're not going to use workflows ahead. Workflows in. Oh, well, the thing is, yeah, I suppose we pass on. We're not going to combine these. We're not going to combine these rules. Are we? Because I've been thinking, like, a rule. The reason I've been thinking about going from the back was that you have a rule that does go to A eventually, but has to pass several conditions, or rather, it has to fail several conditions before it gets sent to A. Right? They might get sent elsewhere. So like that's one way to collapse things. You're not needing to go through four whatever. You just have like one set of ranges that applies to the whole list of rules. But if you go from this direction, now you're saying four different ranges to four different whatever places are being sent, right? And then now you need to recursively go to each of those four places. Some like memorizing, I suppose. I don't know if I should go backwards or not. I really don't. Because if we do this, we're going to traverse through the whole tree. We're going to get to something like, I don't know, CFG in possibly multiple ways. Let's look at all of our, right? So these are all of our flows. I guess each of these are pretty short. Yeah, each of these are pretty short. But you have FPJ. A lot of these get sent to XZ. FPJ could end up sending you to multiple places. But if they are all, so each rule can send you four different places. So it says times 4 times 4 times 4 times 4. That does blow up. Let me think about it. Math.pow 4 to the 4th. Oops. 256. That's not so bad. Okay, we will continue doing it from the front. Okay, so for each of these, we then end up adding a lot more states. We have a state, and we have like we have a bunch of ranges. So ranges, and then we have like a name for where it is. I think I'm kind of afraid of a Stack Overflow, so I'm gonna do this as an unfold. So we're gonna do like a lazy list unfold, and at each step we will have a bunch of ranges, and we'll have like a bunch of positions. So we'll have like a map from string ranges exactly, and then we start with in and start ranges. I don't know what this code is. Apparently thought I'd like it. Um, and this feels like cheating to have something like this go. Um, okay, workflows. If workflows is empty, sure. These aren't workflows though. So this is a name. Those are oh, hold on. Yeah, I wouldn't call these workflows. These are our states. And then at some point, like we're accumulating answers. So like we'll move in, and then we'll have like 4 different places in the map that each go to a bunch of ranges. And then at some point, we'll get a set of ranges for accept. Yeah. And then we can take like the union of all of those accept states. Mm, right? This is a set of ranges. So we have states and we have accepting. Mm, okay, and then once states is empty, then we are done. We just take the union of all of these, right? I suppose we could like output any accepting ranges as we get it. Like what is the output if we're like unfolding from here? I think we're iterating. Well, anyway, inside of here, we're gonna have to do something, right? That something is gonna look like for each of these states, we apply states.map. So we have a name and we have ranges. And then we filter the ranges by action for that rule. Ranges that filter by action. Oh, hold on. No, we don't apply any workflow to a part. So we have the workflow. Valid rules equals workflows for the name. For each of those rules, we'll add something to the map. Right, and then we can just remove the in altogether from our states. Yeah. Rules.map. So for each rule, we are going to get like a name and then new ranges for that name. And then this is just going to be like ranges dot filter by that rule. And we still don't really know how to handle a reject. I suppose like ranges go to 0. And in that case, well, nothing new gets added. I guess it depends on if this rule is a send, right? So we'll match on that rule then. Case send to yeah, sure. We'll call it 2. And then we have 2 to this is the action. Ranges not filter by rule. Okay. And then if it's an accept, we do in those cases. So case reject. I suppose we like it's a reject, we do nothing with it. And if it's an accept, then we're going to add it to our valid ranges or whatever. I'm going to turn this into a recursive function. Def search. We'll make it tail recursive. And the end result is a bunch of acceptance ranges. So we'll do like a set of ranges. So acceptable set of ranges. Here we go. And then states, this can be our map from string to ranges. That's something within which we are searching. Right? And then whenever states is empty, then we just return acceptable. Otherwise, I'm going to get rid of that. And we're going to turn this into a collect. So states collect. We have names and ranges. we want to do like a filter here. um, val sending. Um, and this can be states for each set of names and ranges. We have this kind of thing going on. We're just going to collect all the sends. And yeah, there we go. That all gets added back to the state map. So now we can like search recursively. At some point down here, we're searching. So we're searching with, I guess just sending. You don't care. Might be a flat map. Right, sending will be a map of string to ranges. So this is going to be, we'll do this as a from equals map.from. We're getting strings and ranges. And states.flatMap. So for each state, we end up getting a list of two and filter by rule. But now, what if like multiple workflows send to the same to range? Let's make this a list first. The states, not list, not flat map, because then you might have to combine them. So what do we call this? So these are things I've been sent, and then sent that group by the first part. Case name, range, like multiple ranges. And then we are going to combine these ranges. Not that way though. So ranges dot, what is the type of this? It should know. Right, this should be a list of ranges. Let's give this a type. It's going to be a list of string. Oh, that's why two lists is missing here, so it doesn't know. String to ranges, right? And now we have a list of a bunch of ranges. Ranges S. And we want to take the union of each of those ranges, because those are ranges of values that can get to that position in the tree. So let's add that method in real quick. I don't think we need any of this stuff here. I'm just gonna comment this out while we're working on the union. So class ranges union other def union other ranges exactly. This is not quite what I want. Other.x.flat map interval.union. X. Oh wait. This is an interval. Okay. X is a list of intervals, and only flat map interval dot union. That is another list of intervals. We don't need to list this. So that should compile. Just get that out. Okay, so we can take a union of multiple ranges now. Yeah. So sent, I guess we can just map values. Sent dot view dot map values union. And I guess this whole thing could be like a group map reduce. So just the group by. Oh, hold on. Sent that group by. We'll do this. Sent dot group map reduce. Okay, group by the name. And then the map takes a string and ranges, each of those values. I think we just want to have the ranges and reduce them with union. Exactly. And that is the map. So this can just be called. Okay. Now in our recursive search, we can do sending. And then now we have like acceptable, all of our acceptable sets. And then I guess acceptable could just be the ranges. And we keep taking unions. But then like we have to start it with, we'll just add them one by one. And val accepting. Not quite that. So this can be a set of ranges. And we are going to union that with acceptable. And we're not going to do something that collect. We're just going to do something that's similar up here. States to list flat map. Right. Yeah, almost the same. Except now, when we look at these rules, we are only collecting accept cases. Oh, hold up. What if what if multiple rules? Yeah, if rules are in order, then the conditions add up. So for a particular set of rules or list of rules, we still need we need to like chain conditions together. We need to combine them. So these are all the rules that collect. Need to like hold left on these rules. Um, yeah, in fact, for each of the X, N, A, S, we need to do something. Okay. Well, X. Mm, we're gonna move this outside of this here. Um, uh, def can pass. Okay, so given a set of rules, it look. No, I think given a set of rules. Let's see. We want a function. I'll return a map given a list of rules from like location, so name to a set of ranges that will make it through to that name. And then we're gonna have like a scan left. I guess the rules are applicable. Yeah. Rules that scan left. Hmm. We're gonna start. What are we gonna start with? Hmm. I think this should start. This should take a name. Is we're gonna start with a name. Look for stuff that can't pass each rule to get to a rule that can pass, right? I'm gonna rename can pass. Allowed interval. Accepted. Um, Matching intervals and non-matching. If non-matching. Okay, and we basically do the opposite. Well, not quite. Yeah, yeah. this this here should be just empty. Not quite. Not sure about that. Lollylol, 1975. This is Scala. It's It's a JVM language that focuses on functional programming. Mm. So we need to find, so for every rule, we're doing a scan left here because for every rule in the list of rules, we need to fail all the initial rules before getting to that rule. What we could do is like take the inits. Yeah, let's do something like this real quick. So let's say val, we just have like 125.to list. And list.inits. So we don't want the first one, but we can zip that. So what we're gonna do like that tail, and then we're gonna zip that with list.reverse. Is that tail? We're gonna do a drop one. Drop one. Yeah. And then the thing on the right is like the rule that we can pass to give us like another like send location. And then the stuff on the left is all the stuff that has to kind of not pass before we get there. Hmm. Rules at inits.drop one. That zip. Rules at reverse dot map. Yeah, dot map. And then we have must fail, rules that must fail, and then must pass. And I suppose what we get. I'd done a string here. Go like any action. I think we want the action, and then what ranges can get us to that action. Then we can separate out like accept actions. Yeah, what ranges will hit what action, basically. We'll call this action ranges. Okay. And now we can take the must fail. And for each of those rules, we can do like non-matching for all the categories. I guess we have to do the same thing for each of our XMAS. How did I find this transition from Scala 2 to Scala 3? Let's see. A lot of my transition was done 2 years ago at the 2021 Advent of Code. And it's been nice. There are a lot of niceties in it. And even back then, it was fine and usable. And it's been getting like the tooling right now is great for it. We finally have feature parity with VS Code and adjustmentals in general for Scala 2 and 3. And the syntax has been nice. The enums have been nice. Um, I like how the givens and using works. Yeah. There are a lot of cases where Scala 3 reads nicer than Scala 2. Okay, so X. I guess we do like must fail map non-matching for X. Oh wait, we had to filter by. Filter by. Oh yeah, given a range, you filter that whole range by a rule to say what passes. So filter. If you want another filter, oh, what's this condition? Why is this allowed interval? What was allowed interval? Hasn't compiled properly yet. Allowed interval? um, right. It's matching. It's now matching. Allowed interval. And I guess we could just call it like filter not by. Allowed interval becomes matching. So filter by the rule, filter not by. Yeah, let's call it that. Oh, what's this thing going on here? Some other action. Doesn't seem quite right. That will like infinite loop us. Really? This is by like a conditional rule. Yeah. I still don't know what to do about like rejects and accepts. I guess if it's an accept, I mean, if it's an accept, then that's fine. This is what matches for that accept. And if it's a reject, and we match that condition, then I guess it's just empty the opposite ranges. So non-matching. I think for now, I want this to be just on conditionals. We'll figure that out. So the filter not by. And then we can do the condition not matching. Okay. Now we have what we need for this action ranges. Oh, Lieutenant Hummus, thank you for the follow. Yeah, enums are nice. Implicits, use IntelliJ. I've always hated how IntelliJ doesn't use a presentation compiler and can get like. So I don't know how. I'm sure they have great support for Scala 3, but I don't have first-hand experience there. The reason I'm using VS Code and not Emacs is because of Scala 3 support. Okay, so X, so we take our must fail things and we map, this is a list of rules. We map filter not by. And then I guess we take the union of all those rules. I guess we have to take the intersection of all those rules. If you can get through all of those, if your range is tight enough that you can get through all of those, then that's like a passing range, which we then union. with the filter by for must pass, right? That makes sense. So now we don't have to do this on x's. We can just do this on anything. So filter not by, we need to be able to take the intersection of two rules. We have two ranges rather. So we had a def union. Let's take a def intersection. Intersect other ranges. Copilot should be able to autocomplete this. Let me double check it. Interval dot intersect flat map over that. Yeah, that's right. Let's just boilerplate. And now that we have a, so we're gonna reduce this with intersect. Actually, we should fold left because must fail can be empty. And if we're reducing this with an intersection, I suppose our base case is the full ranges. I'm going to find ranges.full. So do we have an object ranges? Object ranges and def full. I guess it's this exactly the start ranges. Whoops. Okay, that works. Now we can go to our action ranges and we're just going to fold left on this must fail. Fold left ranges.full and then intersect yada yada. So val passed through the others. And then must pass. Oh, I think I know how to handle accepts in our must fail now, or in, what is it? Must fail. We need to map on this first. Map filter not by. Right. And then we fold left those ranges. And then we take past through, and then we union that with must pass. So union must pass dot filter by must pass. Hold on. Def filter by the rule. Must pass is a rule. Oh, I guess we take these ranges, right? The pass through and we filter by the last rule. Okay. Great. So now I guess we return whatever action we have from this must pass. Must pass is a rule. Okay. Must pass, match, some sort of action. Oh, and what if it's some other rule? Then we get the action that would come from that rule. So what do we have under rule? I want this to be an exhaustive match. Match exhaustive, here we go. So if we accept, then map of accept through, well, all the way. We're just gonna call this all the way. I don't know what to call it. Yeah. And now if this is a reject, I mean, I guess we also just say that and we'll handle the rejects later. So map reject through pass through. Or empty? We don't know. We're not quite sure yet. Through all the way. I don't like that there are two things here in scope. I'm just gonna do this real quick. Well, this is like an F, and then what we're gonna turn is F not filtered by path must pass. We're just gonna chain this. I don't want to name things. Hold left, and then now it's folded. We filter by must pass, and then now it's just passed through. Yeah, it looks like given any action, given some condition, we already had that condition. Yeah, so case A action, then map A pass through. We can remove those lines. If it's conditional, then we already handled that condition, and we're just gonna go action pass through. Okay, so for each of these, we end up with a map. And we do have to merge maps. I'm gonna just define a method for merging these maps. Def merge or you know, let's just do it in here. We can pull it out into a method if we're using it elsewhere. So val maps. So we're given a list of rules. Then we can so we're gonna take maps dot group map reduce. And take the union of those ranges. There we go. That's our merge maps. Not found, filter not by. Filter not by is defined. Filter not by rule. Yeah, it's right there. Oh, hold on. It's range dot filter not by. What are we mapping? So these are a bunch of list of rules. It's a list of rules, and for each rule, we take range. I guess we have range dot full. Yeah. So that takes a range to a range. I think this whole thing can be part of the fold left. Right? So like we filter not by that rule. Okay. I'm not gonna do that there. Range is not full. Here's our ranges and filter not by the rule that you're adding. And then at the end of all that, filter by must pass. There we go. That's cleaner. Map reduce is not a member of an iterator. Okay, so we'll do like maps dot to list, sure. So E is a map from action to ranges. Oh, I guess we flatten this, right? Maps dot. What is value maps? This is a list, an iterator maps. Let's to list.flat map that. In fact, this is going to be a list of tuples. This should be a list of maps. There we go. Let's make this a list of action to ranges. So this can be a to list that flat map. Pairings, ranges. We'll call this like ranges. And then ranges like group map reduce. We found something weird. We required purple once. Oh, this seems to be a normal map up here. Right. Yeah. For each of these pairings, we only end up at one final range and an action. And then actually, in that case, we don't need a group map reduce. Right, so we can take this out, and this can be like a map.from. Through. What is pass through? Oh, no. This is our must pass. We just want the action from that must pass. There we go. Yeah, we don't need this group map reduce. Well, actually, we might. We might, because there might be like, we've seen cases where several have the same action, right? Several rules have the same action, just different filters. And that works. Okay, where were we using that? We were using that in the search state somewhere. I'm not even testing that. Like, I followed the types. Belver, the stream goes hard. What makes you say that? Man, I'm so focused. I'm missing chats. I have like audio notifications here in my ear so I can hear them. I turn down the music for myself. Okay, that looks good. So now we're searching if status is empty, and we return acceptable. Yes, so sending. We need the action ranges for a list of rules. So map string goes to a bunch of ranges. We have like a name. Dates. We have a string and ranges. So that's like our current location. And now we take the workflow. So we have rules. And we take the action ranges for those rules. And then we filter on those actions. So action ranges for workflow's name. And then we're going to match on that. Or we're going to collect. Collect. And 2 goes to and ranges. So these are only things that get sent. um, I guess after that, they're sent, we do group map reduce. Well, actually, okay, action ranges is already, it's already a map. So this turns it into, what is result val r? Oh, wait, what did I do here? Okay, val r equals that. Yeah, this is a map from string to ranges already. And that's what we want. So we don't need to do this like states, flat map, whatever. Oh, I guess we have to merge these maps. So send.group map reduce. Yeah, so for every one of those states, now accepting is going to be similar. States to this flat map, same kind of match here. And then action ranges. I guess I could do this part separately, right? And then just filter them all out to the end. So yeah, get all the action ranges. Well, action ranges. And basically, for each of these states that map. So we have like name, ranges, and then we just return these action ranges. And not gonna do any kind of collecting on them. And we're gonna do like a big group map reduce. And this is a map from action to range. And then val next states equals action ranges dot filter, or you know we can do a collect. And this should still return a new map, right? Yeah. Collect case action ranges. I don't like that. I think you want to match on action. That's the case. Send to and ranges. Then we do to ranges. Yeah, exactly. Great. Now the value string to range. Val additional acceptable. New acceptable, I guess. It's action ranges dot collect. All of those ranges. And then now we can continue searching. So what do we do? Like next states, and acceptable plus plus. Let's do like a union to acceptable. And we're just gonna take like the union of all of those, like the actual union of all of those later. What would I see this with? I guess we would see this with like empty range, and then you take Yeah, and then that gets bigger over time. The full mix of val. And we're also going to define empty, val empty. Mm, I think we want at least one interval there. But I mean, that's a thought. Like, how does union work with a? Would that work? So union with empty ranges. Other dot x, that flat map, it would still be empty. I think we need a list of at least one thing. Interval and 0 until 0. I have a bunch of empty intervals. Leaves that map. What's wrong here? We found a list of rules. We need an action. Wait, that seems fine. Oh yeah, it was just okay. Here, found a list of rule. Action ranges takes a list of rules. Okay, so workflows gives you a list of rules. Action ranges. Oh, hold on. Right, we accidentally shadowed. We'll just call this like the ranges. Maybe we'll just call it the actions. There we go. And now ranges here is a bunch of maps of actions and I think we want to flat map this into these, all these tuples. Ranges, hold on, states. It's a map. Let's list that. List. Okay, now ranges is a list of action and ranges. Group map produce that. It has an issue with that. Oh, range. This is ranges. Okay, there we go. So this we can call actions. We'll do a plus here. No acceptable. This is an iterable of ranges. I guess we can plus that. I mean, I think we should just union these as soon as we can, right? That's the whole point of defining these empty ranges that we've done. I don't know. We'll leave it that way. I don't want to think about like folding left and handling base cases. Start ranges. Is there a problem here? Head on an empty range. We're never calling. Immutable.range. This was just fine a moment ago, right? I don't know what changed to make that not fine. Okay, we should just do our search. Um, def search. So our initial states is map from in to ranges.full and set.empty. Right, and we get a bunch of ranges after that. Is there an issue with this? Okay, there's like a compile error somewhere early on. Nope, just there. Oh, wait. We don't def search. There we go. Um, now, acceptable ranges. Acceptable ranges that reduce. We're just going to reduce it with union. Start ranges. We're doing something with start ranges. We don't use that anymore. What was our ends one? Okay, hit on an empty range. When are we ever doing head on an empty range? Right, that's the same error that's showing up for this. We're just defining full ranges. And this formerly was fine. Let me look at my ranges type. Maybe in here I have like a val. Filter not by, filter by. Yeah, I don't see. Okay, let's follow the stack trace a little bit more closely. Range.min, why are we doing a min at all anywhere? So during ranges, lazy initialization, range.min is coming from AOC interval.apply. Scala 147, let's look at that. Double Z3D, welcome to the channel. Thanks for the follow. If you have an issue with this apply method, going for a range, range.min to range.max. I'm not passing it any empty ranges though. Not here anyway. Oh, I see what's happening. Lazy initialization of this val empty. I don't have, I suppose I don't have a way of defining. Yeah, my interval type doesn't handle those. Okay, great. So what happens if I do end up with empty ranges? I mean, I should just like delete them, right? There should just be like an option. Yeah, whenever we're intersecting, it's like an option of range, option of interval. So we just get none. We just have no ranges. And then our code probably handles that fine. Implementation is missing. Yes, I believe that. So let's go up to, okay, filter not by, filter by. Okay, so filter by is saying what ranges are left when we use this rule. Like what ranges, like for send, if it's conditional, I guess we really only filter by conditions. Yeah. Now if there's a reject, I think we still do the same thing, right? We just want to know which ones will go to the reject, which ranges will go to the reject. all it cares is about is a conditional. If the rule is an action, then it's just going to be this, the same set of ranges. So we can delete this, and it's just going to be this. Okay, now is attempting the search. And I've done a lot of merging as I go. Kind of crazy that I'm just now running code, isn't it? So here's our search method on the left. I don't think it's gonna stack. Oh, well, okay. Is this tail recursive? Yeah, this is tail recursive. It's not gonna stack overflow because of that. Okay, we ran out of heap space. Okay, so that shouldn't be happening. We need to merge more aggressively because how many like locations do we have? It's something like 800, and this map should never have more than one of any of those, right? Um, next states. This set of ranges is probably getting big. I'm actually like unioning them. Um, so I mean, let's start with an empty range. We can't actually really define an empty range, can we? Okay, so some slight lack of foresight here. My interval type class interval. How has this not bitten me before? No, we have a min and a max. We could do it 0 to 0. And then that wouldn't change anything. We just make sure to remove it from the end. So let's start with acceptable is just the ranges. And then we're going to take all these new acceptable and we're going to, oh, hold on. We're going to fold left on these. Fold left. If there are none of them, we just go with the acceptable we have so far. Otherwise, we union those ranges together. Okay. That makes things a little bit better. If states is empty, what we return is now ranges. Oh, wait. States is never going to be empty. That's a problem. Well, what the states have, it basically has strings for locations, and then the ranges that apply for those locations. Once we hit, and we collect only those sends, right? So these are basically only send actions. And then once we hit a reject or accept, then if all of these go to an accept, then we're good. Okay. let's test this from a smaller part, see how things are working. So not from in, but from something that goes to A. Um, like LV. And LV should just be the full range. So map from LV. And this isn't going to be a set.empty. It's going to be interval 0 to 0. That's not defined. Oh, I guess range is dot empty. It's gonna it's gonna be that. Um, okay. This is gonna be range is dot empty. Okay. So our ranges, we have a list of ranges here. Everything's gonna include 0, 0. And I wonder if this still works. Oh, 1 to 238. Ah, interesting. There's like a 239 missing in there. That should, I think, be there. That's like an off by something, off by one somewhere. Let's just test. What if this is just an empty list? We still get the same answer. No, we don't. Um, and how? X dot flat map. Yeah, and then we take the other X dot flat map. If either of them are empty, you can't really take unions. Should sort of handle that, but I think we're sort of fine. Okay, well, oh no, we don't want to do that. We don't want to do that. I'm just gonna do a better toString on this. So override def toString. X, and then, yeah, exactly, something like this. X dot make string, whatever. Do we do new lines? No, we're not gonna do new lines. M, A, S. Okay, that should do us. Ranges, X is all of those. Let's take out the space after this comma in all of these cases. Those ranges aren't merged. 1 to 238. They should at least be sorted. 239 doesn't get added. So let's look at the union. Or rather, filter not by non-matching. Okay, matching and non-matching. Matching, I'm pretty confident that's correct. Non-matching. I handwrote this, and this was Copilot. Um, Okay, so if less than, then to not match less than, then we should do V 4000, because then it's greater than or equal. And greater than, this should be 1, 2V. And now this last case here, I knew Copilot was wrong. Oh, sorry, I'm blocking this. This last case here, let's put on the left side. What is this other case? So category, if the category does not even apply, then I guess this stays full, like everything doesn't match. Yeah, everything doesn't match, everything matches. Yeah, they're not exactly like opposites. Hmm. Right? If the category doesn't match, then this doesn't match. Okay. Let's do more tests here. Where are we? Right here. So that looks a little bit better. Right, like it's still a bunch of separate. Oh, that should be deduped when you like take unions. I should make those be like sets of I don't know. It's probably fine. So what goes to LV? Let's look at things that go to LV. EM. Yeah, let's just try that. Whoops. CM. What gets accepted from CM? Oh, does everything make it to A, really? Um, I don't believe that. It goes to FVBL, it goes to LV, and it goes to FF. If it fails everything, it goes to FF. So let's see what FF is. And FF, if A is less than 305, you go A, otherwise rejected. Oh, you know, let's take a look at that. Search from FF. Yeah, this is what's accepted from FF. A must be over 305, so 1 must not be. Oh, hold up. A must be less than 305 to get accepted. But everything else here would get rejected. Yeah. Mm, okay. So those should be rejected. Ugh. I'm gonna take a quick bathroom break. I'll be right back. Alrighty, I am back. Okay, so this is definitely false. It's true that those A ranges go to accepted, but to get those ranges, yeah, and everything else goes to rejected. Hmm. Okay, let's look at what would happen here. We have FF. We have we have these rules. We have these action ranges. Let's get the action ranges for FF, and then these ranges we don't even use. We don't even use the current ranges. We need to be using that. Okay, but first let's get the action ranges for FF. Oh, right, workflow FF. And let's make sure this is still good. So reject all of those. Accept is wrong. So those are the ranges that go to reject. And yes, all of those other ranges would go to accept from here. You know what? I guess it is true. Right? It doesn't matter what the other values are. It gets rejected. Just a less than 3 or 4. So like x being high or whatever. Oh, but x being high wouldn't match this. So that gets ignored. And that's why I think I'm not doing is ignoring that. Let's look. Yeah, those accept ranges are wrong. Those reject ranges are correct. Anything in those would go to the reject ranges because accept needs to have just that. Okay, and reject is the last one on the list. So what happens, we look for what goes to A. I guess you'd have to take like a union, right? Let's look at our action ranges here. So these are things that must fail. There's nothing that must fail. So must pass is just A. This pass through must fail folded. We have ranges not full. So this is just gonna be ranges up full, not filter by. So that's what's happening. And let's look at the rules for that. So workflows of FF. And let's take the first one. Ahead. And let's take a full range. And we'll filter by that. So full. So range is not full, but filter by this. There we go. Those are the ranges that will will pass this test and take its action. So filter by shouldn't return 1 to 4,000 if it doesn't match. Filter not by can do that. So def filter by. Um, hmm, um, hold up here. Oh, filtering by a rule, right? It might only apply to A. We we are already like a set of ranges, XMAS. Um, and yeah, let's say it only applies to X. And yeah, I guess the ranges that get this, everything else has to be 0. I mean, to an extent, no. As long as within those ranges there is an X that matches, like an item that fits in those ranges, it's still going to pass through, right? And it doesn't matter what the other values are. Um, yeah, so the rule applies to any range of the other values. Yeah, so that's fine. So why do we think this is wrong then? Yeah, scroll all the way to the bottom. This is way too long. uh, okay, so we have FF in here somewhere. Right. I think when we're defining action ranges is where things should change. So filter by itself in itself is fine. Um, so this is a case where the must pass is less than A. And if that must pass, then we take our ranges, we filter that. Yeah, I mean, let's just test this. So, of course, that's totally fine. Action ranges for FF. Um, these values will be rejected, and these values will be accepted. Any value of M, X, M, or S. Yeah, it doesn't matter. It'll be rejected. Okay, yes, these. I guess that's what looked wrong, is they both had 1 to 4,000. But 1 to 4,000 is fine, appearing in both sides, right? Because all that matters is A. Okay, let's look at something that goes to FF. FF, where else is up here? FFG, DFF, DFF, FFG, CM. Yeah, I guess that's where you first found it. CM gets you full ranges. Okay, let's look at action ranges. Close CM. How did it know? Okay, so Let's do for each print line here. So these ranges will get sent to FF, and most of those ranges will get sent to an accept, right? Those other ranges will get sent to LV and VBL. Okay, let's look at this. Let's get send FF. So action ranges, what happens to send FF? So that's the range. Um, and I guess this map, yeah, FF to this. So it gets sent to search. If we search from that range, so like we're doing a lot of testing around here, but everything we're testing so far is actually working. I think I do need to just look for more places to collapse things. String, oh, right. That's separate parameters. Search, oh, this needs to be a map actually. Map of FF to those ranges. Wait, what does search take? String to a bunch of ranges, action ranges. Oh, let's do like dot values of that. Dot values. Okay, what is this about? This thing here is a ranges. Okay, we just wrap that in a list actually. List of ranges required just a range. Oh, a map of thing to range, right? Sure. And then search has another parameter. What if we just put that range? No. We're gonna do like set of, or rather the interval. Interval 0 to 0, sure. Oh, acceptable is a ranges that empty, I guess. Okay, and this is what ends up getting accepted. And again, it's because these ranges here are not being used to filter any of these. So I guess all of these ranges, so these action ranges, map values, all of these, so two ranges need to be intersected with this dot intersect ranges. There we go. We're now using that parameter. Wait. Ranges here. That's just normal ranges. So this is a ranges, and you can intersect that with another range. Well, hold on. We're not gonna do it there. Here, so action ranges. A map from actions to ranges. Given a set of rules, right? And each of those ranges needs to be intersected. So we want to like map values of that. View.map values intersect the ranges not to list. Okay, now something like this, that looks a lot better. Oh wait, no, that's just the ranges here. This, okay, those are the values that can get accepted. Exactly, perfect, perfect. So this works. That looks a lot better. LV, yeah, that's good. Let's just try a full search. So we have acceptable ranges, search, map, in, set.empty. And then we can reduce that with union. And we have to do something with that. What's the something we have to do with that? Those ranges. Of all possible distinct combinations of rating, your job is to figure out which ones will be accepted. Okay. There are that many combinations. Okay, so we will reduce this with union to a single range. Final range. Didn't search just return? Yeah, that should just return the ranges. So we don't need to reduce that anymore. Okay, so acceptable ranges dot x dot size dot too long. We'll just make a combinations method instead of ranges. So class ranges def combinations equals. Okay, there are all these intervals. So let's do x dot map all these intervals. Presumably they're already a union, like to set it. So we have a bunch of unique intervals. Dot map dot size dot too long minus one. We're gonna do x dot distinct. We don't want to do that on a set. Too long minus one. Now and minus one because of the 0, 0. Mn and Sn. And we multiply them. Okay, so acceptable ranges dot combinations is the answer. Val ends 2 equals acceptable ranges dot combinations. Yeah. All this stuff here we don't need anymore. Just try this. Wait, set dot empty. No. Do ranges dot empty. And this is where it runs for a few seconds. But so on our search, like I think perhaps we need to do some pruning. Well, no, we shouldn't need to do some pruning. Because how many strings are there? Right? This map is always going to be like there's a constant size limit on it. We'll add more ranges for each of those, and ranges will always be one value. So we're not going to run out of memory. Hey, is this running? As it's evaluated right away. Oh, other problems. Distinct. I see. Long non-member list event. Oh, yeah, so we sum that. Maybe we put it too long. The size is going to add up to less than 4,000. We're good. And did it run? Using indexes to guess a definition is too long. Why would it need to do that? Okay, this is running for 30 seconds already. Are there just too many? Or is there an infinite loop in here somewhere? Hate that. I would hate that. No, because I've looked through these ranges, right? We had our scratch output. It's not gonna be an infinite loop. Oh, here we go. Oh, okay, those are paths for all the parts. But every one of these paths ends in like 1, 2, 3, 4, 5, 6 iterations. Why would this be slow? Mm, I mean, is there? It could be that there's a value that would infinite loop in circles. We could draw. We could draw a tree. Oh, hey, is it still? Did it evaluate it? Hold on. Out of memory error Java heap space. Why would that be the case? This is a map of string. There are only so many string values. Workflows. What size? Did we kill this? Okay. We start that. Each iteration of search. Why would we run out of heap space? Oh, you know what? We need to do an object to make something tail recursive. So I'm just going to put this inside of one. Oops. Just say like depth search here. The dot range it foo dot search states unacceptable. Possibly be computing. Okay. Yeah. Search from other places. I'll just search arbitrarily. I don't know, CPV. What goes from CPV to accept? The as long as A is less than 3005 and S is in that range. Interesting. A lot of other things get rejected. Oh yes, so there's a rejection here, then an A. I mean that looks good, right? Take out the 0 to zeros. Let's look at SZS. That should just be everything. So this is a test of that. SZS. Interestingly, oh wait, not everything there goes to an A. Well, if M is over 3306. Oh yeah, just split the ranges. 3306, oh, whatever. My union function, my ranges doesn't go distinct. Maybe I'm getting like too many ranges, too large number of ranges. So let's do this point.scala def union of intervals. The intersection is empty. I guess when this is not here, it is actually my day 19. Def union here. It should be like a dot distinct at the end. Quite, not quite. So that happens after the flat map. Okay, take another look at that. Down here, we should have all these zeros. Okay, cool, and they remain sorted. Well, let's keep trying arbitrary stuff. Working in Go. So in, a lot of them can go to FPJ or V. Everything else goes to KX. Let's see if we can do KX. Or let's see where KX goes. KX. Oh, KX is pretty small. Oh, no, it's TKX. KX goes to VHC or GN. It defaults to GN. That's from KX. KX. GN. GN. Oops. Goes to JMN. Let's try JMN. Okay, JMM works fine. Let's try GN. Is it gonna be because we had like way too many 0, 0 ranges? Okay, what went to GN? What defaulted to GN? KX. And that's where in defaulted to KX. Oh, so we can totally do this. All we need to do is for me to remove those zeros. That's it, right there. Okay. Answer is too high. All right. Let's look at one that only that sends everything to A. A. There's one of these in here somewhere. Yeah, like DV. Oh wait, no. Go back to 219. Let's try DV. That is full ranges, right? So that should be 4,000 times 4,000, whatever. Let's take that. Dot combinations. Make sure we're doing the math right. Okay, yeah, 256. And a bunch of sets of zeros, right? 4,000 L times whatever is the same thing. So we're computing that portion properly. We're able to get an answer pretty fast. Yeah, like a second. Oh, that looks too large, doesn't it? Yeah, because this is the maximum up here. Let's do this. We'll copy this over. We just want to compare the numbers. Okay, somehow our combinations, combinations. Okay, x dot distinct. We can make an assertion here that each of these are all distinct. So assert x dot combinations of 2 dot for all base, um, list A, B, intersection should be empty. And we can do that for every one of these. If this assertion fails. Uh, okay, that assertion fails somewhere. They were not distinct. Okay, our union method. Maybe our intersect method. We're not checking that these are all distinct. Although, I mean, I think that should still be the case. Um, okay, union of two lists of intervals. This isn't quite right, is it? Oh, we have to diff out first. Okay, let's define separately union of, I guess, two sets of ranges. Yeah, let's do this. Def union, and this is n interval, and then ends, which is a list of interval. And this list of intervals should be disjoint. And what we're first going to do, we can't just do union. We need to do ends.map diff by n, right? Whoops. Which returns a list of ranges. I'm going to flat map call distinct. Flat map dot distinct. So we've taken n out of all of these. I don't think we actually need to call distinct. But then now we fold left this with the union. Fold left with n as a base, and then union. Okay, now we can use that in here. And we have x dot flat map. Or, you know, we have like a fold left. Yeah. X dot fold left. If there's nothing in x, then we take other dot x. Otherwise, we do union, the new union function. Flat map to the other is a bunch of ranges. Other dot x is a list of ranges. Okay, so x dot fold left. Let's do this. X dot fold left. Other dot x. I don't like the underscore union here. That's not what I was trying to use. Operation. We're building a list of intervals. So B is our accumulator, list of intervals, and then we take an interval of int. Yeah, and then these are the union function here. Those two. Let's change the order. Order doesn't matter here. Union doesn't work on ranges. Oh, it's going to be the other ranges. Interval union. Let's call it that. Interval union. And we'll just pass in interval union. And call it the end. I don't think should be necessary. I mean, maybe it is. Maybe it is. Oh, yeah. So there's like an integral type, and then that goes to each of these intervals. Yeah. Oh wait. This is just n. Here we go. When we are using like ints, we could just make this int. Okay. Now we write all of these again. Um, find a list of interval. This should return the list of interval exactly. Yes. Okay, this fold left. We have an interval for our base case. This is a bunch of intervals right here. Those flat maps into a bunch of intervals. Let's straight up make this interval over ints. A is an interval. B is an interval. You should just be able to call that union. Whatever. Okay, so that works. No, it hasn't. Still has an issue. Required. F equals that. Then f dot fold left. What's the type of f? This is a list of interval. A union B returns a list of intervals, right? Yeah. Well, I guess we have list of n. Yeah, like the accumulator type. Well, okay, we're taking the interval, the union of all of these. Okay, we're taking all our ends. Let's map in with diff uh, dot diff against n. We get a bunch of like remainders. So like we flat map this, right? Flat map. Now we have a list of a bunch of intervals. Each of these, we take a union, right? So case. Guess we have an accumulator here. Everything that's been unioned so far. And we're unioning one more thing into there. So we'll do like an act.flat map, whatever union B. Then I could do like a dot distinct call at the end. Or rather we do like B onto act dot flat map diff. Dot yeah, now we fold left again. We fold left. I guess we start with like an empty list of things that we're unioning. We could just have n, list of n. Yeah. So we diff B out of those. Um, and is that it? How do we defer to the union defined here? Def union. Okay. So for unioning against multiple, we put this in here. So def union against intervals, which is some seek of interval, sure. And intervals that fold left is disjoint is a good name. But disjoint is only true if you first diff them all out. I don't know, I think I'm fine with this being here. We don't really need to union this. So like we've diffed B out of all of these other ones. So we don't need to union any of these against B. We just ons B onto the list of them be diffed out. Yeah. Okay. I think that's better. I'm gonna have to do something similar for intersects. Oh, that's all always 256 billion or whatever that is. Essentially, this is 1,000, 1 million, billion, trillion. So 256 trillion combinations. Okay, we broke something. Def union, other ranges. Hmm. Again, we use this interval union. Let's try this interval union. Test it out. So interval union, this interval 1 to 10, and then interval 5 to 15, sure. So 1 through 4, 5 to 15. Okay, now let's have several that overlap. Um, Interval 11 to 20, and interval 25 to 30. Okay, that is fine. We are splitting them up more than we want to. And now what if we have multiple ranges? So let's say we take this. So val ends equals that. And we gotta take ends dot hold left and in with other things. So list interval let's just do small ones, 1 to 5, and then 11 to 15, sure. We fold left. We fold left with that other. What if we do like other? That fold left with this. I might prefer that. Yeah, let's do it this way. That fold left, base case, ends, and then we're gonna do interval union, see where that spits out. Yeah, I mean, those all get diffed out. Let's have another interval. Interval 0 to 40. Oh, wait. This and sp. Yeah, let's just do that. Oh, right, we just get that interval. Let's have -10, 5, and 25 to 40. Essentially, you get 25 to 40. Um, that seems to be working. So, what's going on like here? That's still correct. These are all full ranges to 4,000 though, and that wasn't happening before. Um, I suppose that shouldn't necessarily be a fold. There's nothing with which to union. I mean, I guess yeah, it would be. It would be the other. How does this? Which definitely like looks correct. How does that break things? Are we unioning with a 4,000 at some point? Range is at full. One of these range is at full. Okay, in the search. Um, right, there's a bunch of ranges here. We intersect everything with ranges. Oh, what's going on? We broke it. Okay, we're gonna save def interval union. This one. We're gonna keep this. In fact, we might put it over in point. Comment it out for use later. We'll also leave that commented out because we'll want that. And we're just gonna undo until we get back to whatever the original unions were. We'll compare them. Yeah, you're iterating over that. Okay. And dot flat map interval. Interval dot union. The problem was this was that we weren't necessarily getting problem with this is that we weren't necessarily getting disjoint unions. We want disjoint unions. So for every value in this interval here, like assuming x itself is disjoint, other dot m, see what answer this is giving us. It's giving us an answer that's too big because the unions are too large, right? That's exactly it. Yeah, right. So my ranges here, a list of ranges, will have some that overlap. So before I union with another range, I need to like diff out everything that we have. So take my interval, and that's what I thought I wrote. And when I tested it, that seemed fine, but in the final answer, it was always a 4,000 range. So other.m, we're going to diff all of these. Map. Okay. Flat map. Diff practice interval. Right, that's like all we kind of really need to do. And then we can flat map interval that union. But here's the thing: when we flat map interval that union, we add those back into we add this back into each of those. So we don't need to flat map interval.union. What we need to do is take interval onto that. Okay, so for each interval, we diff out the other thing completely, and then add that interval to it. But now we're going to get duplicates for each of those that we did. So actually, for every one of these, yeah, that's why I went and like wrote a different function. Let's just write a function that gets like the interval of two ranges all of two lists of intervals altogether. Yeah. Um, yeah, this doesn't work because we need to diff like all of these against each other. This needs to be like a fold left, right? X dot fold left. And if there are none of them, we get other dot x. Um, which is going to be another list of intervals, right? And then we have an accumulator and a b, or rather an interval earlier. Interval. And what do we do with that interval? We do the same thing we do here, so that we take that interval, cause it until like what we've accumulated so far, while removing it from everything that we've accumulated so far, right? Flat map diff interval. Flat map diff interval, and then that's good, right? And we do like a dot distinct at the end of all of this, but again, shouldn't be necessary. I don't know what this other flat map is from. Wait, let's take a closer look at what it came from. I think it was code that we'd removed. Okay, interval. And this is what we do, the interval. Move that forward. This is 2. This is 2 squared. Lemny, do I know you IRL? It is all in a giant monad. That's a problem. Uh, but I did forget the Fubnicator. You're right about that. Okay, I'm gonna comment out all these old ones so I have it for reference. I'm gonna delete these and we're gonna re-implement them. We're gonna ask Copilot to implement them. A equals, come on. Come on, you can do this. S equals. It should be a function that like I can test separately. Oh, we can't have a comma here. I guess we can do like a dot distinct, dot comma. Sure. Gift of the internet. Well, welcome, welcome. Gift of the internet. Okay, let's see what this does. What's happening, what's been happening is that I can correctly calculate like a range. I'll look for the end. Um, and it'll be like a valid range, but then I'm unable to calculate the number of combinations properly because a lot of my ranges overlap. I'm trying to remove those overlaps. Do we have any issues here? Found list of interval required an interval. This thing here, we don't need that. I'm gonna ignore that for now. Yeah. Hey, that's looking better. That's smaller, isn't it? I think you showed up just in time to see me solve it just before 4 a.m. Yep, there it is. Answer's too low. Okay, okay. So, whatever the previous answer was too high. I mean, these acceptable ranges. Um, you know what? We should have a way to like normalize these ranges, make them easier to see. You're like a good luck troll. And if I succeed, I'll get 3 wishes. Succeed at what? This problem. And I make a wish that you grant. I make a wish in advance. And if you grant it, I promise to finish the problem. And I'll throw away the other 2 wishes. Okay, what am I scrolling around for? I want to look at this answer here. Ah, we're gonna go class ranges, and we're just gonna make this a little bit easier to read. So def normalize. So copy and x equals x dot sort by min dot distinct, and we'll do that for each of them. Okay. So let's print acceptable ranges, but normalized. Oh, in our search, we're just gonna normalize here. Normalize. There we go. Now every time we do a search, we'll get a normalized range. Just uncomment all of these and see if they still look good. Uh, is it working? Is it struggling? It doesn't seem to even be attempting to compute the worksheet. 1, you can't wish for more wishes. 2, your wishes must be written in Perl. Oh no. I'm out of wishes then. Does Perl have print line? My wish is print line. I wish to finish this problem. Semicolon. I don't know Perl. Um, True facts. Um, what are the combinations for each of these? Okay, JMM, I know that's like pretty close to the end. How's I doing? So X's. I think I want to look at each of these action ranges, or just the workflows. Let's look at workflows for DV. Right, like this would make sense that all of those get accepted. Yeah, because there's an accept catch-all at the end. Workflows for KX. And KX, basically, um, it sends to BHC or to GN. Oh, is GN the one that sends to? Okay, let's look at all of these and try to kind of sort them out. Um, GN. Oh, I think I know what I've been doing. So like I was looking at all the catch-alls. Okay, this sends to KX, sends to GN, GN sends to JMM, JMM, which defaults to BGC. GC goes to KQC. Oh, this is a lot of these. Oh, KQC. KQC. Which ones go to DV? That's, I think, what I wanted to find out. So, DV, close curly brace. No, nothing goes to DV. Really? I mean, nothing defaults to DV. One thing can go to DV, and it's SCZ. So we have SCV. Wait, SCV? SCZ. I'm playing StarCraft. I can't stop writing V. There we go. You should be off. Until next time. All right. Have a good night. Good luck with your admin of code if you're doing it. Yeah, and let's look at CZ here. Right. And I don't know. Let's look at the size of this. Be less than 256. Oh, it's not size. What do we call it? Combinations. That's slightly less than 256 trillion. So that's what you'd expect there. Winkle, hi. I felt the need to stop by and say I finally brought down my dreaded day 5 from 150 to 47 microseconds yesterday. Great, great. What did you change? Oh, yes, right. You need to do some sort of interval thing. Did you go with an interval type or did you try something else? Um, this answer is too low. We're undercounting now. How could we possibly be undercounting? When we take the intersection, do we need to do anything fancy? Def intersect. Let me intersect another range. We take all our intervals. We take all the other intervals. We intersect them against our interval. Right, we get a bunch of optional smaller intervals. I don't see how this could make us undercount. This could be like a smaller thing. Oh, you know what we haven't done in a while? Let's try this on the example. In fact, I don't think we've done that ever. But there's that many numbers. Okay. Okay, so now let's look at our ands too. As soon as it comes up, wait, it should be done. Not found FF. Oh, all these tests are not going to work. Let's comment them all out. See what we get. Wait, we have another thing. There's an FF happening still. Here we go. Okay. So whatever this is, it looks like it's higher. Um, against whatever. Yeah, it's higher. We're still overcounting. You'd be overcounting in the intersect def. Intersect. Because I feel pretty happy about what we did with it here. So let's say we have disjoint unions or whatever. We have a disjoint union. And we intersect all of those. Let me think. So let's say we have ranges like 1 to 10 and 20 to 30. And we're going to intersect that with 1 to 5 and 8 to 12. Right? So here we'll get like 1 to, when we're intersecting 1 to 5, we're going to get 1 to 5 and that's it. And then when we're intersecting with the other one, we're going to get 8 to 10 and 11. Well, yeah, I can't see a case here. We're taking all our intervals, which are disjoint, and we're intersecting every one of them against all of the other intervals. In the other set. So we have a big old interval that gets brought down. something tiny. But none of those are going to overlap with the other because it's disjoint. I should put like an assert on my constructor. Where do we have asserts? We're doing asserts in like combinations. Def union of two ranges. We could make an assert here after the fact. It's 5 hours. Yes, it's been. Is it 5 hours? 4 hours and 12 minutes. We have performance. We have nice models. We just have like an off by something somewhere. Okay, let's look at what our acceptable ranges are with the example set. And you know what? We can kind of like manually check this, right? I think it's time for some sort of manual check. Def2 string. I'm going to change this. Well, no, it's fine. It's fine. Maybe we'll copy the worksheet output into Scratch so we can read this. Acceptable ranges. So we have X. Then we have M, A. Believe it or not, I just now started trying it on the samples. What I've done for testing is go through some of these states that are close to A's. And I've done like, combination sizes on those. And they seem fine. Right? In fact, here, let's look at something that does go to an A. CRN, we could check that. We could check a UKC. Yeah. So let's search from CRN. Oh, no. CRN and then ranges dot full. No, ranges dot empty. Need to map from CRN to ranges dot full. Okay. Let's see what that turns up. Oh, wait. This is in the Scratch. It's not real code. Here we go. Okay. So for CRN, well, we could also do like, what's our function called? Action ranges. Okay, let's look at the action ranges for CRN. Workflows for CRN. Okay, so those things get mapped to reject. And like that, we're pretty confident in. It's if the X value is too low, it gets mapped to reject. And then it doesn't matter what the M, A, and S is because it's not going to get accepted. And an accept is just the opposite, right? So the accept, when we do the search here, 1 through 4,000, 1 through 4. Oh, how did our accept become the full range again? I guess we started with full ranges. This isn't what was happening earlier. I should have more commits while I'm working. Are you dealing with complements correctly? Well, the latest thing I fixed was my unions. I was making sure they were disjoint unions. And I did fix complements at some point. I was making sure, like the filter by, filter not by, like what squeezes arranged smaller was working properly, and that I'm pretty happy with. So I don't think it's that. You see smoke coming out of my head, but there aren't even any gears turning in there. My brain's too cool right now is a problem. I need some heat up in there. Yeah, I mean, like I looked at my output for part one, and I mapped out all the command chains you can get for any of these things. I was like at most six, right? And if you're branching like four to the sixth power or whatever, the search space was small enough. I didn't care about it. So like the search space is not an issue at all. I'm not worried about performance. I'm just worried about some math. I can't math. Um, okay, this is patently wrong. We have um, are we taking unions incorrectly now? Let's look at my search. Ranges. Okay, so we have our map from string full ranges. We only get that one set of full ranges. And the only way we use it is we intersect against it, right? Um, so we get the action ranges, which you saw below, which looked correct, right? It had the S value was smaller or something. And we intersect, yeah, we intersect all those ranges against this full ranges. So we should get the same thing. So this next state's here. We collect all of these ranges that are sending elsewhere, and all these ranges are acceptable. Hold left with acceptable ranges. Acceptable ranges starts as an empty range, um, or rather like the 0, 0 range or whatever. And we just union all those ranges, but there's only one range. Um, yeah, let's add a print line here. Print line, or let's do like a ranges for each print line. What action ranges we're getting, or actions, I guess, actions for each print line. And then new acceptable, for some reason, it's ending up 4,000 when we collect all the accept ranges from here. And if there's only one, then like taking the union out of them, if it is empty, it will take acceptable, which is going to be empty, right? Okay, so let's look at the print line that happens when we search from CRN. These are my reject ranges, these are my accept ranges. This is the thing I'm taking the union of. So X should be 2663, whatever. We just saw what that was printing. Okay. Let's go look at that. No, not for in. We want for CRN. So it's new acceptable. We find all those accept ranges, right? And then we fold left them. But when we fold left them, there's only one thing. because there's only one accept range. We add another print line here. Accept range to union. And yeah, exactly that. We're going to return it. Now when we call this again, there's only one there's only one thing, right? And then we're reducing that. We're reducing that by folding left with acceptable. Acceptable here being ranges.empty. So we union that with the empty range. Okay, why don't we try doing the union of that? So ranges.empty dot union, and it's this action ranges workflow. What does this return? Hold on. Okay, so we want the range for accept. That union range for accept. In fact, let's look at that separately here. Okay, so this is a range. And okay, we've broken our union function. Clearly. So let's take a look at our union function again. MC is me Prague. Hi, welcome to the chat. What I'm taking the unions of. Oh, good question. There's probably a good reason for it. Let's see. Union. Oh, I mean like here. Right? So there might be multiple paths to an accept, right? So I take my accept, and I take all those paths to accept, and they each have a range associated with them. I just take the union of all those ranges. And similarly here, might have multiple paths to the same key, and every time I find a path to that key, I do this like group map reduce union, make sure they are merged down. So that keeps my search tree small. So this map of string and ranges, it's only have one string, and those ranges are unioned here, right? So this map is never going to get larger than 500, however our input size is. Yes, it is apparently doing that. Returns 1 to 4,000. And let me see what I changed. I've had a few iterations of this. Like if we go back, the CRN, the one that matters here is X. So let's just change just the X and see what answer we get for CRN. And we will get, oh, no. We don't have that interval union method anymore. We want something like this. This is our original thing that we wrote that has the issue of not being, not resulting in a set of discrete unions, right? Disjoint unions. So this is X. Others that X.flatMap. I wonder if we have other M, other A, other S. Sure. So changing this, we need a comment. we'll make this give the correct answer. Now if we do, wait, where is it? Search for CRN. Yeah, that'll give us the correct answer. So this is essentially what we want, but then I like iterate on this to remove any overlaps. So other.x, before we can flat map interval.union, in fact, we're not even going to flat map interval.union. Let's take that out. We're going to take other.x, and we're going to diff all of those against this interval. Flat map dot diff, so we're going to subtract this interval, and we're going to add this, after subtracting that interval from all of these, we're going to add that interval back at the start. There, right? So we try that. Wait, are we extra paren? There we go. Okay, so we try that. And now our search here, this is still correct. But we had issues with this, didn't we? I don't know. I'm just gonna try this again, I suppose. What's the difference between this and whatever's going here? Well, we might have multiple intervals, all of which need to be diffed out against. So we're gonna iterate on this once again and hope we're still getting like the correct answer. So we're taking the union of each of these, which with a bunch of these other things. And the problem with that is now that bunch of other things appears in each of these unions. So we need to do an x.fold left. And we have the other interval, so other.x. We'll just leave it the old thing here. Other.x. Fold left other.x, and then now we have our intervals. We have our interval, we have our accumulator, right? And I guess our accumulator is everything that's been, oh, there it is, there it is. This bit of accumulator hasn't been unioned properly yet. I guess we could combine them. Bounce them together, no. Okay, I figured out what a mistake is in this bit here. This m.fold left other m. The other m hasn't been diffed properly yet. Oh, actually, you know what? It does get diffed properly because we take the accumulator and then we do this whole diffing thing, right? So other.x becomes ac. And our interval, this is the accumulator, which starts as other.x, flat map diff interval, cons this interval against it, and then this becomes our new accumulator, which we diff out all the other stuff against. So this should still work. And call a dot distinct again. I don't think it's necessary. But let's see how this changes here. Um, 12662. That's still correct, right? 2663 to 4000. That is correct. So it seems right. Let's go back to this very original one to give us the same answer. We do not have duplicate paths. Hold on, I'm missing some messages here. How am I unioning them? Okay, I think I've just shown how I union them. LR for each of XMAS. Yes, I do it for each of XMAS. And again, that's only for like combining these later. Like what I could do, I could skip the whole union thing altogether by instead of using a map from string to ranges, we could do like a list of string to ranges, and we could just keep going all the way through that list and flat mapping into a larger list. Like I would get it. Oh, this is not the one we want. Where was the original dumb one? X.flat map, other X.flat map. There's no diff. The one that has no diff. It's gone. But any of these other ones had worked previously, right? 1 to 2662. I'm just making sure it makes sense. Oh, wait, I see it. I see it. See all these others? They don't use the accumulator. They don't use ACK. Okay, that's what it is right there. Give me a second. Oh, yeah. Okay. So that seems correct. We're back. We're back to this. Back to this 256 trillion. So I'm gonna sleep on this, and when I wake up in the morning, it'll come easily. I'm sure it will. But thanks for stopping by. Let's just raid someone real quick. Time Android is still on. Hey, Alka's on. Let's just raid Alka. Or wait, is anyone actually doing Advent of Code? Yeah, let's raid Alka. Yeah, I guess it's been the longest stream in a while. All right. Thanks, everyone. Have a good night. We'll see you rest of the year.